Fine. Very good morning, one and all. Uh, we just continue with the module 2. You completed module 5 kinematics. Before going to it, I'll just brief it out what we have been did from the module 2, starting it. Module 2, we have analysis of non-concurrent. In that, again, we have a 2 units. Number 1 is your equilibrium is unit 1. Number 2 is your friction. That is unit number 2. You have 2 unit in the module 2. Okay. Now, what do you mean by an equilibrium? You know that you say body is in equilibrium means the body should be at rest. If you want to say the body to be at rest, either you need to apply another opposite force where the body is moving, you can make a body at rest, or mathematically how I can define an equilibrium is the summation of all the horizontal component acting on a body and the summation of all the vertical component acting on a body should be equal to 0. If both h and v is equal to 0, it is understood that the resultant of the body is 0. Then I can say the body is in equilibrium. Even though I can't say the body is in equilibrium, why? Because it should satisfy one more condition. See, not only moving, the rotational effect is also a matter where you can stop the body in moving. That is called as moment. You understand the concept of moment? No, moment is nothing but rotational effect on a body or product of magnitude of the force into perpendicular distance. You should make the moment, the resultant, both the things should be equal to 0. Then only I can say the body is in equilibrium or it is at rest position. You are going to solve lots of problem based on this particular concept. You have been already solved it. In that, another important concept, what are the conditions of equilibrium? Say this is a one important thing you solved in module 1, resolving it, equating all the horizontal component, equating all the vertical component. Yes or no? You have been given many problems, you're resolving it, you're equating it. Okay, now what you should do, you resolve the same thing, you equate it, and you equate it to 0. That's it. That is nothing but we have a 3 conditions here. Summation of h is equal to 0, that is horizontal component. Summation of v is equal to 0, that is vertical component. And the moment at any point on a body should be equal to 0. These are the 3 conditions of equilibrium. They may have some question in exam. Define equilibrium. What are the conditions of equilibrium? You need to state what is equilibrium. What are the conditions of equilibrium? Hope many have been written this already in your class notes. The next one, you can see here equilibrium of forces. In that, the most important question, expected question, always the last for 6 marks, state and prove Lamin's theorem and what are its applications and limitations. This is for 6 marks or 8 marks sometimes. Not only state and prove, you have another 2 questions in this. What is its application? What is its limitation? You should know the application part of it. You should know the limitations of using Lamin's theorem. Now you can only see the figure and not mention the statement and all here. Hope you already know, but I'll explain the statement once again. The statement state, if 3 coplanar forces acting simultaneously on a body, if 3 coplanar concurrent forces acting simultaneously on a body, then the 3 forces are in equilibrium. Then the 3 forces are in equilibrium. We can define each force is directly proportional to the sine of the angle between other 2 forces. That is a statement. I repeat one more time. If 3 coplanar concurrent forces acting on a body, simultaneously acting on a body, are in equilibrium, then each force is directly proportional to the sine of the angle between other 2 forces. Here you have a 3 forces, that is F1, F2, F3 are the 3 forces. The angle between them is alpha, beta, and gamma. Then according to the statement, what you need to prove is F1 is directly proportional to sine alpha, F2 is directly proportional to sine beta, F3 is directly proportional to sine gamma. Now, if you equated this equation, removing the constant of proportionality, you can obtain a one equation, that is F1 divided by sine alpha is equal to F2 divided by sine beta is equal to F3 divided by sine gamma, and the entire thing will be equal to the constant K. See, the free body diagram is nothing but it is some pictorial representation or a diagrammatic representation which is isolated from the contact surfaces. You know that there is a first example, can you see there? You have a sphere which is being connected with a rough surface at the bottom of the ground. That is called as a connected surface where have been given archings. That is a connected surface. If you want to draw the free body for this means, what you should do means, you need to isolate from the contact surface. Isolate is nothing but remove the contact surface, and you show in a figure format which all the forces should act on it. See, if you just remove a contact surface, you know that when one body is in contact with another body, the reaction will be developed. That is reaction, we call it as R. And by default, the weight of the body will always act vertically downwards. Do you have, for the first example, you have one force that is W, another force that is R, and you remove the contact surfaces. You can see that figure. There I not written a sphere. If you return a sphere, if you not written a sphere is no matter. I want you to write the quadrants. That's it. Why? Because that is where you can solve the problem very easily. Write the quadrants properly there. Always divide into a quadrant, first, second, third, fourth. Now you see the W is acting downwards exactly since it is a weight. And the R is acting upwards because it is a reaction normal to the body. Is it clear? That is your first example. The free body diagram is a diagrammatic representation which is isolated from the contact surface, and that free body is also in equilibrium. That you need to understand. It is, you can't say the body is not in equilibrium. It is in equilibrium. Then only I can apply a Lamin's theorem, or then only I can apply the conditions of equilibrium to solve the problem. So this is the first thing. You can see the second example here. I think you have been solved that problem. You remember the first many have been solved that problem. Okay, see, there is a two sides of the wall, one side, and one, the sphere has been connected to the one side of the wall, another thing is been connected to a wire or a rope. Okay, therefore you can see how to draw the free body diagram there. You have the first thing, I not given the angle, you please ignore it. You angle should be there, or you can assume an angle when you're solving a problem. See, the sphere first has been contacted with the first side of the wall, that is right end of the wall. That is nothing but the reaction which is moving towards the horizontal positive axis. Next one is the weight of the body is always acting vertically downwards. Now the one thing, that is a rope, you have a tension in the rope, that is in your second quadrant, that you can observe, and the angle should be given, that is not there, you can assume, and it will be given in problem. That is a second example. You can see a third example also. The third example, you have a same notch. The sphere is in contact with the three sides of the notch. That is, you're from the horizontal, two sides on the, one is vertical and two sides on the horizontal, three side it has been attached. So you can, the free body, you can see there, the free body, that is nothing but R1 acting upwards, R2 towards the positive axis, R3 towards the negative axis, and W will be the normal weight of the body, always acting downwards. Likewise, you should draw lots of free body diagram in upcoming problem. Please be aware of that. Without drawing it, it is very difficult to solve the problem. So you should able to draw free body. You have some 2-3 marks for that only. Please draw free body, look at the figure properly, then you put the free body. The best thing how I can help you out in drawing means, first you divide a quadrant, then you see where the forces is acting, that you can substitute in that particular quadrants. That's it. Don't write like sphere, nothing else. Don't write anything. Only divide a quadrant. You put all the forces according to the quadrant. Enough. That will be the free body. And always observe the free body should be from different points. It is always from the nodal point. Nodal means from that point all the forces is moving. Concurrent point we call it as. That point only you should draw. For this, you can see the nodal point is a center point. O will be the nodal point. That means you are drawing a free body at the point O. Or you may have only one sphere here. In upcoming problem, you can see some 3 spheres, 2 sphere, 3 or 4 forces, 3 or 4 free body diagram. That is called as connected bodies. So you should know which one to take first. S1, S2, O1, O2, like that. Depends on the problem. Hope it is clear, everyone. I think you have been already solved this problem, but then also I'm just brushing it out. Many people are like forgotten it. I want everyone to understand it. Okay. You don't need to write it. Already you have been written. I'll give a time for what you should write. Next, this is already I explained the conditions of equilibrium. Horizontal should be equal to 0, vertical should be equal to 0, and the moment at any point, it not only they will be specifying, or you can specify at any point the body should not rotate. The movement of the body should be nil. Then only I can say it is in equilibrium. These are some conditions. Okay, next. This is very, very important before solving a problem. There are some note that you should always think about it. You should always look at this note. Why? Because people have a confusion. What is arrow marks? whether it is towards a body or away from a body, whether the body is in tension, whether the body is in compression. Always please be clear in that. Don't get confused with an arrow mark when you're solving a problem. That is where I have been given some note for you. That is, you can see that strings, wires, rope, always this is subjected to tension. Tension is nothing but the reaction is moving away from the body. It is not towards a body. The arrow mark you can see there, R1 and R2 are always away from the point O because it is a wire. It is connected to the two sides of the wall. Therefore, the arrow is R1 outwards, R2 is also outwards from the point O, and always the weight of the body will be downwards. So when you see there is a wire, rope, or a strings, whatever you can call it at in the problem, the reaction arrow is outwards. The same thing when you see a sphere which is connected with any contact surfaces, there you can see it is always considered as a compression. That is nothing but the body is moving towards the point. The arrow is towards the point. You can see R1 and R2 are towards the point. Oh, see the arrow mark. These two differences is very much important to solve a problem. Clear everyone? Hope you are understanding it. Please concentrate the difference between what is compression, what is tension, what is string, what is rope, or what is wire, or what is sphere. All this you need to understand to solve a problem. That is what I have been given just for your understanding note. They won't ask this and all in exam. This is for understanding to solve your problems. Clear? Now, the next, another one important concept, very, very important it is, because you have lots of problem in paper also, you can see many problem based on this. This is called as a frictionless pulley. You can see in the olden days, normally outside you have an open well, they have been tied with a steel rope. Two ropes will be there, one rope with a bucket which has been fallen to the open well, another side you're standing it and you're holding that bucket. I think you can visualize that. Okay, that is your the best example that I can leave. That is your frictionless pulley. The pulley or the rope, we don't have any friction out of it, but it is in equilibrium condition. See, if you put a weight, you can move towards the well, or if you put a weight, you can pull it out the well from the bucket, you can pull a water out. That means whatever the reaction will be there, it will be in a tension format. If you move that side, you're going to fall on the well. If you pull it out, you can pull the water out by using the same rope. That means the weight, which is a W, the tension will be equal to the weight of the body. Hope you know the Lamin's theorem can be applied only when you have three forces. The maximum minimum should be three forces. More than that, you have any forces. For example, if you have a four forces, you can't apply a Lamin's theorem. You should go for equations of equilibrium. That is nothing but sigma h and sigma v. You equate it, you resolve it, equate to zero. Everybody, two identical rollers, each of weight 200 Newton, each of weight 200 Newton, are placed in a notch, or placed in a notch as shown in the figure below, or placed in a notch as shown in the figure below. Assuming all the contact surfaces are smooth. Assuming all the contact surfaces are smooth, comma, find the reaction developed at the contact surfaces. Find the reaction developed at the contact surfaces. Mark it as important. You can take down the figure there. See the figure, please be very clear. It is not exactly horizontal. That is been inclined with an angle of 30 degree. You can see the figure clearly. You have a notch. Inside the notch, you have a two spheres. Each of weight is 200 already given. You have know what is a contact surfaces. Sometimes they only given in a figure the alphabets A, B, C, D. Sometimes they're not going to give that contact surface A, B, C, D. You need to understand where is a contact. Okay, it's already given in the problem. And the angle of inclination is 30 degree with respect to the horizontal. You can see the one horizontal line, the notch is been inclined with 30 degree. Clear? Now, what is a question actually? Please observe very clearly. They didn't ask anything here. They only ask you to find a contact surfaces. That is, you need to find what is a reaction at A. The A is for the first pair, that is O2 1. RB, RB is for the O2, O1. You have RC. This is where everyone should understand clearly. Can you see this C? What is that C? This is your contact surface. That is nothing but it is your connected body. The one body is being connected to another body. You remember you have been solved some string problem where a same rope is being connected to the two ends of the free bodies, that is O1 and O2. Same way you have a C point is very very important. The reaction at C will be there for O1 also. The reaction of C will be for O2 also. Don't disturb. Okay, and the last one is reaction at D, which is horizontal. Okay, yes, what they said is correct. You need to draw the two free body diagram for this problem to solve it. The second question here, which is the first free body diagram that I should take? Look at here, many know how to do it. You need to take O1 as a first free body diagram, O2 as a second free body diagram. The reason is very simple. O1, please check it out, how many number of forces or the reaction is acting. Now the number one is 200 Newton weight, which is acting vertically downwards. Number second one is RB. RB is a reaction, and you know that it is your sphere. The reaction will be inwards. Now it is inwards, not outwards. And you have RC. So you have a three reactions for O1. So you should take this first. When it comes to O2, you have a four reaction, 200, RD, RA, and RC. So the first free body you need to consider is O1. Okay. Yes. The first thing is considering the free body diagram at the point O1. You see that figure clearly. See, after giving that notes, you need to understand. Likewise, I have been written it. Please concentrate looking at the figure. See, O1, before drawing the free body, you should understand how it looks exactly. Number one is RB. RB is moving towards the second quadrant. You know, there is a line, we call it as a tangent. 90 degree will be there, any line which means exactly 90 degree. Already the 30 degree one side has been given. You can frame a triangle, yes or no? 90, 30. The remaining is how much? 60. Therefore, the angle for RB, which is in your second quadrant, angle is your 60 degree. Meanwhile, you want to know there is one more reaction there. Everyone can observe the reaction RC. RC reaction, please look at here in the figure. RC C point is here. That means when you're considering O1, it is towards a body. The RC is moving for which quadrant it is? First quadrant. Therefore, the angle should be there. The angle is, can you see this side, everyone? Have been said that have been drawn. That is nothing but the RC line and the inclination are parallel to each other. That is nothing but the reaction for RC, the angle is 30 with respect to x-axis because this RC line and the inclination are parallel to each other. That is where it is your 30 degree. I've been clearly written also. Angle for RB 60 degree with respect to x-axis from the triangle, and angle for RC is 30 degree with respect to x-axis because it is having a parallel line with respect to the inclination. Therefore, it is 30 degree. Is it clear, everyone? Since RC reaction parallel to the tangent, therefore the three reaction forces acting at the point there are three reaction. I repeat, number one is 200, number two is your RB in a second quadrant, in your first quadrant, and the final figure look like this. The Lamin's theorem. I think you can solve it. Please understand here. Number one, 200 Newton vertically downwards. That is your weight of the body. Number two, RB reaction. Angle is 60 degree with respect to x-axis. Number 3, RC angle is 30 degree with respect to x-axis. The rest, everything you can solve it, I guess. That is nothing but you can apply Lamine's theorem to calculate the answer for RB and RC. I only divided everything there, all the angle. For 200 Newton, two sides are RB and RC. The angle between them is 60 plus 30, 90. For RC, the two sides are RB and 200. The angle between them is 150 because 60 plus 90 is 150. Similar way, for RB, the two sides are RC and 200. The angle between them is 120. That is your 90 plus 30. Already divided. Kindly please apply your Lamine's theorem. Lamine's theorem states that each force is divided by sine of the angle between other two sides. The answer for RC is 100 Newton. The answer for RB is 173 Newtons. Is it correct? Hope so. I have been written everything. Only you need to substitute. Take out your calci. Equating this two equation, that is cross multiplying it. Equating RC, that two equation cross multiplying it. RB 200 into sine 20 by sine 120 divided by sine 90. RC is 200 sine 150 divided by sine 90. I think everyone got the same answer. RC is 100 and RB is 173. The next part, can you just please observe there? This is now considering a free body diagram for the O2 line. Same thing, similarly, you please draw it. Please observe here everyone carefully. Number one, I said you already, there are four forces acting on it. Number one is weight of the body, 200 Newton, exactly downwards. Number two, RD. Can you see RD there? Which is exactly horizontal and it is moving towards the positive axis. That is exactly horizontal. Number three, you have your RA, exactly similar to that you have been calculated as RB, no? Same way RA, which is moving in a second quadrant, 90 degree, 30 degree and 60 degree with respect to the x-axis. And the next one is RC also to be considered. Many will go wrong here only. Many will forgot to take that RC line. Reason, RC will be there for both the thing because it is a connected body. When you are considering free body at O2, it is in your first quadrant. When you are considering free body diagram for O1, the RC will be in your which quadrant? Third quadrant, opposite to it. Very clearly you can understand that. Opposite to that, it is in your third quadrant. Therefore, the RC value already known. You have been calculated in the previous free body diagram. It is your 100 Newton. The arrow mark which is moving towards the third quadrant. Angle remains same since the two lines are parallel. That is 30 degree. Everything is clear. The final figure look like this. Please observe. This is your final figure. What is that? RD moving towards positive x-axis, 200 Newton vertically downwards, and RA which is in your second quadrant, angle is 60 degree, and RC which is in your third quadrant, which the answer is 100 Newton already substituted, and the angle is 30 degree. Now, since you have four forces, you can't apply the Lamine's theorem here. So what I did, I have been going for equations of equilibrium. That is nothing but equating all the horizontal component, equating all the vertical component. To equate it, you need to resolve two things here. Number one, RA, resolve it. That is RA sine theta, RA cos theta, with sine also I have been already resolved it. And the same way 100 Newton, which is RC, that also to be resolved. Both are negative. 100 cos 30, 100 sine 30. Is it clear everything here? Now everyone please take out your calci, equate to 0. Summation of H is equal to 0. Summation of V is equal to 0. You please observe when you're taking sigma H, RD to be taken positive. When you're taking sigma V, minus 200 to be taken positive, negative. Yeah. I think I have been solved it. I think I only written the answers at last. I think you need to solve this everything, equating it. Now, I think that this problem you need to solve. I already written the answers. I want everyone to get these answers. Very similar. I didn't only change the values. That's it. You can take down this as your assignment also. This question also, please post it after solving it. Okay. The answers also I written. Solve the similar method. You can see to it. I'll share these notes to you after this. Please solve the problem. Okay, see the question is same things, two identical rollers of weight 1000 Newton, instead of their 200 you have your 1000 Newton supported on an inclined plane with a vertical wall. Find the reaction of the contact surfaces as shown in the figure. I have been mentioned what are the contact surfaces and the angle is 20 degree. I think you can solve this. Yes, and the answers have been written. Please solve the problem by yourself so you have a practice out of it. fine, ma'am. Can I move to the next?
Yes, Vishnu. Please go to the next problem. I think they've written it down.
They'll be done.
Yeah, this is very, very important. Many times you've been asked in paper. That's what I written again, important there. Please take down the next problem, everyone. A horizontal channel with an inner clearance of 1000 mm. A horizontal channel with an inner clearance of 1000 mm carries two spheres. Carries two spheres of radius 350 mm and 250 mm whose weights are 500 Newton and 400 Newton respectively. Whose weights are 500 Newton and the 400 Newton respectively. Full stop. Find the reactions at all the contact surfaces or all the contacts. You can take down the figure first. Find the reactions at all the contact surfaces. Take down the figure clearly. See, it is a notch. Inside the notch, they have been given a two spheres whose the values is already given. The sphere 1, that is S1, the weight is 400 Newton and the radius is already given. You can see the radius is 350 mm. And for the second sphere, the weight is given as 500 Newton and the radius is 250 mm. That is your S2. And the length of the notch, exactly they have been given it as your 1000 mm. Can you see properly? That is very, very important to solve the problem. That is 1000. And you need to calculate the reactions of the contact surfaces. That is, you can please take down. Number one, you can start with what is RA, what is RB, that is a connected body for S1 and S2. Next, you have RC. Next, you have RD. You need to calculate RA, RB, RC, RD. That is equal to question mark. See, as you know that there are a two sphere S1 and S2. First, you consider S1. Okay, when you are considering S1, first you check me how many forces are there, reactions. 400 Newton vertically downward, no required of any angle, and you can see there is an A point which is exactly moving towards a negative axis. Yes or no? Because the reaction is towards a body, it is a sphere. Therefore, RA moving exactly horizontal in a negative axis. That is RA. And the next one is RB. RB, you can observe there, it is a connected body. Therefore, RB will be there for S1 also. RB will be there for S2 also. When you are taking S1, the RB will be moving towards first quadrant. Or no? Okay. Yeah, when it is moving towards a first quadrant, the angle should be there. That is your task. How to calculate the angle? To calculate the angle for RB, I am only already written, okay? But in exam and all, you can't expect the triangle is already given. They are not given. Please check it out. How to frame a triangle here. Number one, I will join the radius of the two spheres first. That is the radius of the sphere 1. I want everyone to mute. Please don't talk. The radius of the sphere 1 and the radius of the sphere 2. This hypotenuse side is you're going to get directly. Okay. Number 2 is you can't get this S1E. It is highly impossible to get the answer for S1E. You can't get it. It is just a line which has been drawn. That's it. And have been drawn another line S2E. From the center of S2 have been obtained the line as S2E. Therefore, can you see a triangle of S1, S2, SE, S1, S2 and E is a triangle formation over there. Now you should get one other side. Already you got a hypotenuse side because of adding the two radius of S1 and S2. You should get a one more side. Getting a side of S1E is very difficult. You can't get it. You can get the answer of S2E. Now I want the answer from your end. Looking into this figure, how you can get the answer for S2E? Anyone? Shubham, you can tell Shubham, since you have been solved the problem.
So total 1000 minus both the radius.
400, sir.
It is 400, correct?
Yes, yes.
The S2E is 400. Observe everyone,
Yes,
what she's trying to tell means, you know the total distance is 1000 mm.
1000.
Okay. Then you can minus the radius of S1 since it is this side and the radius of S2 from the O1 to D. So you get to know 1000 minus, what is the radius? 1000 minus 350 minus 250.
250.
What is your, yes, answer is 400. Now you got a two sides. One, you got it as your number one, you have your adjacent side, that is S2E as 400. Number two, you have your hypotenuse side. What is the hypotenuse answer? 350 plus 250 is how much?
600. 600.
600. Therefore, the theta, what rule you should apply? Sin theta, cos theta, or tan theta? You have hypotenuse and you have adjacent. You should go for what? Cos theta. Very correct. Therefore, theta is equal to cos inverse of 400 divided by 600. You can see the answer there. This is your triangle formation. Can you just see this? I've been clearly given. You can get this answer as theta value. What is the answer of theta is?
0.7.
48 point. What?
48.2.
48.2. That is the thing. Ma'am, can we stop this so that we can continue in the next class?